Yeah, Prabhu, you're up. Recording's up.
Okay, so today's session is going to be almost like all the SQL Server that I have, all the SQL Server interview questions, or I would say we have prepared. It's almost 17, so we'll cover as much as we can for today. So let's get started on this first one. Sai, is that okay? Or do you want
Yeah,
me to do it?
sure. Let's get
Okay.
started. Yeah.
So the first question is find top 5 recent orders or top 5 records. Okay, so let's say we have an employee table, so we can just format as to make it simple. So employee table, right? So to get started, so top 5 top salaried em- employees. Okay, from employee table. Okay. So Sai has actually Oracle Apex
It's a free account. Anybody can get it.
data.
So yeah, anybody can actually go to apex.oracle.com and then just sign up. This is how the console looks like, but feel free to try it up. I'll put the link in the session in the video description. So Oracle gives out a free sandbox for everybody to play. I will do another session on how to load up the tables and keep the database ready so that you can play. I'll do a separate session on that. But all that is preset before this session. We have preset everything. Yeah.
Yep. So to find, okay, so let me just query this table. So we have a table called EMT. So this is the table. Okay. So what we wanted to find is like top 5 highest salaried employees. Okay, so that's what the question is. So that might be one of the questions. So they might, being a backend developer, they might come up with this question. They cover section by section. So they go for SQL, they go for Java, they go for microservice architecture, then they go from there. So that's why we are covering the basic to start with, so that you get yourself comfortable, and then we move on to the next section. Okay. So this is the table. EMP is the table. So what I'm going to do is I'm going to just order by to find the top 5 salaries. Okay. So if I just query it, it's going to be fine. Okay. So I'm going to just find. So in this list, if they might ask top 5, okay, or 4th highest salary. Okay. Either way. So either way, they might come up with. So if it is a SQL Server, find the top 5. I would just use command like top 5. Okay, that's it. So it should give me what the top 5 is. But they might go with the trickiest question is that, like, what is the 5th record, 5th highest salary, right? So to do that, so we have a function in SQL Server. Okay, that's called row number. Okay. So this number, this is a function. So any programming language. So this is SQL, but any programming language, even Java, is just function is being represented as this, right? So what we're doing is we're writing the function and over. So over of what? So salary. So we are going to find the salary, right? So what we are going to do is, like, we are going to order by salary. Okay. So we are going to find the highest or lowest. So based on that, we would just use the descending or ascending, right? So we are going to use the descending order because we need the highest salary, right? So this would give me a way to assign a number for every record. So this is what is called RN. RN is a row number. I'm just assigning, it's an alias, right? So doing this, so it should give me a way to select the number. What happened? Missing expression. Over order by descending. What happens?
Maybe break it down and order by.
So this is assigning a number, right? So that's it. So then emp dot star. Yeah. So it's basically looking for an table alias. So now we have got the numbers. Okay. So if I want to use, so actually I made a mistake. I should not have done this. So I don't need to do that. So so this particular function is assigning a number for every record. So doing that, so we got the records assigned with a number. So now what we can do is, what I'm going to do is, just going to use RN equal to 4th record. So will it work? So it's not going to work because RN is not part of the table. So it's going to throw an error because RN is a number. I mean, it's a column generated as part of this query. So this query, this table EMP does not have this field. So to get the table with that record, or fourth record, so what I'm going to do is I'm going to make it as an inline view. So inline view is nothing but a table. Okay. So I'm considering the result set of this data, result set of this query as a table. So that is called inline view. So you can give any alias. I'm going to call it as EMP underscore query. Okay. Where I now EMP underscore query alias is an inline view. I mean, alias for the inline view that we have created. It's going to give an option for us to RN. Okay. Now I can select any row I want. Okay. So this should give me the record which I exactly want. So row number function is where many of the cases, any question comes in general, technically that asking for fifth record, 10th record, or you want to delete a particular record. If it is a given order by that particular salary level, so you can simply use row number. So anytime you come up with this kind of question, just go for a row number function. So this is pretty easy if you keep practicing it. That's it. So any questions?
Here I think it's the important thing is the line number 3, how line number 3 is acting as a table. So like so it's right, like EMP underscore query, that has become a table, right? That is a beauty about it. So when he tried to run, when Prabhu tried to do RN equal to 4, it didn't work because it's not at that scope, right, Prabhu? That's called the scope, right?
Yeah, it's not in the scope. I mean, when I say scope, it's basically not part of the table, right? So if you want to use in a where condition, if you want to use any column in a where condition, you should have it in the table. So it's not part of the table. RN is something it's an ad hoc column that we just generated. So in order to
for employee table, when you add RN as a row or new column for this employee table, you still need the whole table, new table. You need a new table, right? So that's why RN was not part of the table, so it was not catching up. So when you said employee underscore query, you gave it alias name. Now on that table, all you're doing is just asking where RN equal to 4. That's it, right?
Yeah.
So this logic can be applied to like the second highest salary or age, like a oldest person or the fourth oldest person in the family. The logic can be implemented pretty much anywhere where you can apply the order on a particular column, and then give a number to the order, and then grab the nth row, right?
Yeah.
Okay, sounds good. Yeah, I think.
Yeah. So the one other variation part of this row number function is you can do partition. So you know what is partition is, right? So when you query a table, right? So when you query a table, so let's say we have a manager. So for this manager, how many employees are there? So how do you find it? So for this manager, how many employees are there? So you can use same function. So we can just simply do where mgr, like mgr is equal to 7839, right? So you can do this. So this is 3 records, right? So same way, you can do a partitioning. So you can, when you do a partitioning, what happens is it assigns a number. The row number function will assign 1, 2, 3 for employees mapped to this particular manager. Then if there's another manager, it's going to assign 1, 2, 3 again. So that way you basically clustering the common by a common property. So basically nothing but what I'm trying to say is for partition by, okay, I'm going to partition by manager field. Okay, so if I do that, let me not run this for a particular record. I'll run it for the whole thing. So if you look at this one, the number is assigned by this partition. Do you see the number? So you can basically 7566 has 2 employees mapped 1 and 2, and 7698 is mapped with 4 employees. So to find how many employees are mapped to particular manager, you can assign the number, manipulate this query with this particular with this row number function. So this is one of the other variation. So for a row number function, what you can do, partition by or order by, two things you can do. So this is the only thing you can do with this. So assigning this values, the row number values, you could delete a particular record. Okay, let's say I want to delete all the employees except keeping the first employee for a given manager. So what you do is you just delete. Okay, let's do this. So basically,
so Prabhu, 1 second. So the partition by manager, what would be the question for this kind of solution? You did the partition, right? Even without partition, we got the earlier solution. So I think we have to spell out the questions, Prabhu, as we speak through.
So so the previous question was find the fourth highest salary. So what you did was you find the fourth highest salary from the entire table. Okay, from the entire table you just found the fourth highest salary. Understood? Yeah.
So when by partition by, you're basically and so
let's say what is the highest salary for a given manager? For each manager, you have 10 employees. Okay. So out of those, who is the highest salaried person? How do you find it?
But which manager?
So, for all the managers, you have 10 managers in your company. So each assigned to 10 employees. You want the highest salary employee for each manager. You want to find it in that organization.
Okay.
So if I do, if I do this, so I'm going to get for every manager who is the highest person. For this guy, he is getting 3,000. For this guy, 7,692. This is the only employee getting the highest salary.
Okay, so run the inner query, the third query. Let's look at how it looks.
That's what I ran actually before. So it's going to assign a number. It's going to assign the number 1, 2 for this group. Basically, it's grouping, right? It's going to group it by the manager. That is what partition does.
Okay.
So the basic meaning of partition is what? Clustering together, right? I mean, partition together for a given field. That's what we are doing here. Oops. Okay.
Okay. Cool.
Okay. Yeah. Let's not waste time. I mean, we get the context, right? So we get the context.
Yeah. Sure.
Okay. So delete a duplicate record. So delete a duplicate record is basically the same functionality. This is one of the interview question I always get asked by any DBA or DB developers. So that's one of the important question. We do the same thing. Okay. So what we can do is I'm going to see. Let's call it as EMP. Okay, EMP query. Okay, I'll just name. So with this class in SQL. I think in Oracle it's the same. Mostly it's SQL Server I have used. So delete from EMP underscore query where RN is greater than 1. So which means, so this is the duplicate query. So this table example is not the perfect example, Sai, but technically what I'm trying to say is you have, I don't have the right example to explain. So I wanted to be able to delete anything in all the employees other than the highest salaried person. Okay. Do you get the question?
Yeah, you want to delete everything except the highest salary.
Highest salaried person. So this could be one of the question, right? So it's the same functionality. You use the row number function, keep it as a subquery or inline view, then delete from, this is a custom name, that alias or whatever you call it as, but that's a custom name. So delete from EMP query where RN is greater than 1. So this way you delete all the records where it's anything more than 1. Okay. So this is a regular scenario in my work. I have used this query many times. Generally speaking, when it comes to data cleanup, this might be the real-time scenario. So recently I have performed, we have a table called 4 million records. Okay. So this is one of the fastest query. I wrote it in my project. So I have to delete this duplicate record to keep it consistent, except keeping 10 record for a given scenario for a particular field actually. So this is one of the useful queries as part of this. So That's
so
why.
you said with the employee underscore query, that is the alias that you have given to that table.
Yeah.
Right. So
Yep.
select, then you are okay. Delete from employee with algorithm. Okay, sounds good.
Yeah. Hey, any question to others? So I just wanted to. I don't know if that makes sense to you to understand, or should I go in a different direction? So tell me, any feedback is good. This is all I'm covering it up all as part of interview perspective. Okay, nothing else.
Yeah, I mean generally is more the reason why even I sit in interview panels. Generally, cracking the interview is the most important thing, and we should focus on that. Once we get through the interview, everybody will do the job. So pretty much, so yeah.
Yeah, speak up if you have any question. Don't worry, even if it is a basic question, it's fine. So don't worry about it.
Yeah, don't take it serious. We even have the bunny coming up and showing up sometimes. So
yeah, that's a relaxation for you. Yeah, let's not take it seriously. Like seriously, it's just a basic thing. Maybe some of you might have gone through it. Why this guy is explaining all this? Maybe you might think. But when you go to an interview, you will never be able to write the simple query. You'll forget. That's the point, actually. So collectively, we'll put together as a PowerPoint presentation, and as a like, I would say it has to be a day-to-day preparation. Every day you just look up once so that you crack the interview without any hassle, right? So that's the whole goal.
Yeah, let's move to the next one.
Okay, so
They have question, they'll unmute and talk.
yeah, and the reason why I did not cover the basic, you can read the basics in online. So I'm just going only through the interview questions. So that's why.
That's good enough. Yeah.
Yeah. So left outer join, right outer join, full outer, self join, and cross join. These are all the basic thing, but mostly people ask for left outer join. So that is one of the main question. If you know one thing, you would do right the rest of the joins actually. So let me get started. I would like to get started on the self join, which is kind of tricky. Why would somebody use a self join? I don't. What is self join first of all? So let me get started on that. Then I'll go from the left out. Okay.
Yeah. Maybe Prabhu, write the comments on the top, just in case somebody joins a little late, right? They'll understand the context. Just write the comments.
Wait. So let me do this. Okay. Self join example. Okay.
Yeah. That would be good. Yeah.
So we have a employee table, right? So in the employee table, we have employee, and we wanted to find the manager, right? So whoever is the manager and what is his name. So how do you do that? So I know this employee 778, Scott, he mapped to this guy, but who is this guy? How do you find it in a simple query? So that's a question, right? So here I'm going to use the same table. Okay, so I'm going to join the same table, mgr. I'm calling it as m. Okay, on e dot. Okay, mgr. E dot emp number equal to m dot. I'm going to call this as mgr. So I should call this as emp. Actually, sorry about that. So I'm going to use the same table to join so that it gets that person's ID. I mean, person's name. So emp name. So I'm going to, what I'm doing is basically I'm doing a self join between the table so that it gives me the person's name. It's pretty simple query, but I just wanted to show you. When they ask, so what is that type? So you might do it with the simple command, but you'll be doing without even knowing what you're doing actually. So this is called self join. Joining the table, the same table itself is what you do it. So this is called self-join.
So what is the question? So what is the question? In what scenario?
So you have
What are we
same
doing?
scenario. So they'll give an employee table, right? So in the employee table, you just want to find the manager name.
Manager names of the employees. That's it.
Employee, right? So
So
that's
select employee, employee name, employee manager, employee M dot employee. So M is manager.
Manager name. Yeah. So I'm joining the table itself with that key, whatever the primary key is.
Okay.
Okay. So this is self join. Okay. So I'm gonna go next. Any question? Just shoot out.
So give me the scenario, like before writing the query, like what is the scenario that is more important? I think left outer join we're writing. So
yeah,
what is one scenario question that you can come up? When would you go for a left outer join? What scenario? What kind of question?
Yeah. Just thinking, because order and customer table is not a good example, but I'm just thinking. Wait, I have written some queries. Let me see if I have the scenario. Yeah. So you can find an employee. So we can use the employee table itself, right? So you can find an employee who is not assigned to an department, right? So let's say you are joining.
Go back to the editor. Go back to the editor. Yeah. Yeah.
So in your organization, you have a new employee, right? So in that organization, you do not, the new employee has not been assigned to an department, right? So that's when you use this left outer join, right?
Okay.
So what I'm doing is I'm going to use employee table and left outer join. So left outer join, if you look at in Google, there are plenty of explanations. So what I'm saying is, like, you have a table where the table has all the employee data. So if they are not assigned to a department, the department field will be null, right? So you just wanted to find out all the employees who has not been assigned to one department. That's the goal.
And also all the employees who have been assigned.
Right? So left outer join, by default, it will do the mapping, only map the data and get the joined column. That's it. That's all it does. Right? So let's do. So I forgot those table names. That's why I just wrote all the queries there. But so do we have a table name?
Department, yes, we have department, yes.
You have it, right? Yeah, I just executed those. So what is that? It's a department number. Right? So this is going to give me all the columns, right? So here, if I do a left outer join, the left outer join will map all the record and give it to me with the employees, whether they are mapped or not mapped. So I wanted to be able to find only the employees that are not mapped. So if I go, it's null, right?
So basically left outer join gives everything, all the employees, whether they are mapped or not, irrespectively, it will give it to you, right?
It'll give everything to you.
Yeah.
So the only case where you do is you use a where condition by that null value. So if the employee table does not have a employee department number map, then that's when you get this record. So you use it in the where condition to get this record. So this is when.
So what you mean to say is, like, the left outer join becomes way more valuable when this situation happens of department being null with the right table not having the value and left table having a value, right?
Right table is basically the mapping table, right? It's basically the key. So all the department will be there, but the left table does not have the value. So what I have used in the where condition is the left table column.
No, other way around, right? So
that's
department, the employee is the left table, department is the right table.
Yeah.
So yeah, left table has the value, but right table doesn't have the value. That is when you use the left.
I mean, if you look at this field, right? So you basically don't have that value on your left table. I mean, you have the record, but that record is not really mapped properly to that specific
The
employee.
department is the right table, right? Not the left table.
I know, but you see that alias here?
Okay. E is the alias. Okay.
Yeah, E is the alias. So where I have the record for an employee, where I just wanted to find the employee is not mapped to a department. I'm just trying to find it. But you can just simply, but this is not a perfect example of left outer join, but you can do, I'll come up with a good example actually. So this tables is not good enough to explain all this because you can just simply do EMP department personnel. It's going to give you all this, right? So it's not perfect example.
So let's look at this one statement, right? Select employees from E, left outer join department D. So what did it do? It is taking all the values of employees and joining with those values for which you have values in the department table, right?
It's everything that's mapped along with the table. It's basically a simple join. That's what it does. So left outer join include, so no, Sai. So look at this way. So you just do inner join, right? If I just do an inner join, what it does is it will look for the field matching this.
Matching both.
Right? So if you do left outer, okay, if you do left outer, whether it is matching or not, okay, from the left table, it will bring everything. Make sense?
Correct.
So it doesn't matter whether you have the right table data in the right table or not, doesn't matter. Based on the join condition, it does not matter to the left outer join. It will bring everything, okay,
Right.
along with the matching record. So out of it, when you put the where condition, it's going to get you the field which is not mapped on the left table. That's it. Not clear?
Okay. Okay. So yeah. So yeah, let's move. Let me share my screen once. So I think so here, let's say you have Venn diagram, and let's say you draw another. This is let's say this is the. This I should think. No, so let's say this is the A rate. So everything here. So if this is the left table and this is the right table, so if this is the employee and this, let's say this is the department, right? So you are saying everything here. Layout. Oh.
So any intersection position, intersecting columns, right? So those columns will be inner join. The intersecting portion of left.
This is the So this part is the inner join, right?
Yeah.
It should be it should be present in both tables.
Both
right?
tables, yes.
So left outer join is like it should be present in this. Everything from this, and it must be present. So left outer join is this part, right? Like everything from this table, and it must
Everything from the left circle will be there. But to get only not the intersecting position, then only use the where condition in the query.
Okay. Oh, okay. Only non-intersecting part.
Non-intersecting part is when you use a where condition to filter out that. That's it.
I did not get that last part, Prabhu. That
Okay, so Sai, can you just color the portion, non-intersecting portion of that circle? So
Fun?
with a different color, like red color. No, not that.
Okay, this part also there, right? Okay.
Yeah,
So,
that's not, we're not going to worry about. So this part, yeah, color that. Yeah, that part is where you use that var class to filter it out. So because this is all the part where you don't have a mapping record in the right side table.
yeah. So where the department is not assigned. So you're
Yes.
trying to filter out red and blue intersection. So
Yes.
what you're trying to get is this part. Okay.
Only
So, so yeah, I should probably draw. I drew it in a very bad way. Let me draw it the proper way. So let's say, so let's say this is the department part. Okay. And this is the, oh, come on. Yeah, I'm sorry. This is the part. And is there a way to, anyways, so this is the part. If this is the blue part and this is the red part. If this is the part, shit. Okay. Okay. I'll stop annotating. So I think I got it, but once.
So the first circle not involving the intersection part is that condition where department is null, you're saying. Prabhu?
Yes, that's what I'm saying. Yes.
Got it.
Yeah. If you want example, like, okay. Sorry.
Yeah, I think we got it, bro. Now we got it, I think. So
yeah, it's like if you want to show it in the picture, like I didn't prepare for that, so
yeah, it's okay. Yeah, we'll move forward. Otherwise, it'll drag on. Yeah. So basically, this part, this is the part which we are trying to. This part, right? Like non-intersecting part.
Yeah, not intersecting part. Yes.
This is the part which we are trying to capture.
Yes, intersecting part is the inner join. Non-intersecting part is the left outer join. Same thing if you do it on the other side, like the same opposite is a right outer join.
Right outer join. If you're trying to get this part, yeah.
Yes.
If you're trying to get.
Yeah, that's it. That's a right outer join. Any department that is not mapped to the employees. So that's when you do right outer join. So there could be department that's not assigned to an employee, right? That's possible, right? How do you find that? Is that clear?
Yeah. So yeah. So basically, when you right outer, so outer join. So outer join is this portion. Right outer join. There's the left outer join. Right. Left outer join is a portion. When you do left outer join, you will get everything from the employee. And let's say this is employee. Let's say this is employee. And let's say this is a department. And employee is the left table. Department is the right table. When you do the left outer join, you will get everything from the employee and the intersecting part from the department.
Along with the intersecting part.
Along with the intersecting part. So typically you will get the whole employee table, right? So now the advantage of left outer join is you will get the red portion where you can say not mapped, where department is not there, you can just get the left outer part. Non-including part you can get. Correct? That is the advantage.
Yes.
So otherwise the whole query will return the entire this part. It will return the whole entire department, entire employee it will get, and right outer join will give you entire department or department table.
Entire department, irrespective of whether the department is mapped to the employee or not.
Yeah. So the only time you can really leverage the fact that it's outer, the outer part is when you add a where condition saying not null, where the other you're excluding the table, right?
Yes. Either null based on your requirement. Based on your requirement, you add a null or not null. Not null, you would use it when all the employees should be mapped to one department, right?
Okay. Sounds good. Yeah, I think we'll move forward. Thank you.
Yeah, okay. So yeah, so to that, so do I have to go through right outer join in this case, or you're good?
That's fine. Let's move forward.
Because it's just the same thing, just opposite way. So to do that, you can just write some queries. I mean, we don't need to spend time on this kind of small things. We just need to understand what exactly it is. That's good enough for a interview. They might ask you to write a query. So you be familiar writing a query, like all the class where you put what join exactly you do it actually. So that's one of the major requirement. Okay, so it's just if you want right, so employee just keep the same query. Okay, write out or join on same department number equal to T dot department number. So this is same thing, right? So that's all.
Yeah, the whole query doesn't change.
Doesn't
So
change.
yeah.
Changes. So if you want to find this,
So this is essentially department table, right? It is the what you get essentially is the department table. Without, if you don't add the where clause, what you get is essentially the department table. You're getting the whole right side.
Yeah. But since it's a join, the result set will have both tables. Whatever it's matched. Oops, sorry. Oh my God. I went this way.
SQL comments. Go click on SQL comments.
Yeah, since it's a browser, it just dragged that way. It's gone. But we can pull up the history, right?
Yeah, you can.
Wow. Okay. Okay.
That's okay. Yeah. Yeah. Idea is the most important thing. Yeah. So it will give you all the information. So if I do select star from, so let's do this. Let's say select star from department, which is not exactly same as right outer join, right? Now, when you do a join, you're getting data from employee table as well as the department table. So if you do a select star from department, you only get the department information, nothing else. But when you do a join,
yeah, since we are doing a join between these two tables, we are getting all the data. So, but what I'm trying to do is, so this is what you do. So you see this one. So what I'm trying to do is like, I'm just only collecting all the, so now this is what it will be. So the right portion of all the department table. So if I go search E dot EMP number is null. So if I do this one, see, there is a department. It's not mapped to an employee yet. Make sense?
Yeah. So you're basically now only doing E dot M. So D dot, okay.
See this? This is
Both
what
these are columns of both the tables.
Both tables,
and both the tables, and this is the right outer join. You are and filtering by E dot employee is null. So you are kicking out the intersection portion by saying is null.
Yes.
Right. The intersection portion is what you are removing.
Yes.
So yeah, basically. So if I go back to my PowerPoint, basically, when you do a join, you get these. So you get these when you do a join. If you don't do a join, it is simple circle. If it's simple circle, but it doesn't have any clue about the other part of the circle, which are other columns. When you do a join, you get columns of this table and columns of this table. But when you add a where condition, you kick out the intersecting part. For a right outer join, you kick out when you kick out the intersecting part, all you're left is the part where this part, the rightmost part is what you're left with. The rightmost part is what you're left with. Same with our other part.
Yep.
Okay, I think we got it. We can move forward. Thanks.
Any other question, guys? Like, I don't know if.
Yeah, I think it's clear. I think it's clear.
It's clear, Prabhu, but when we go through the basics and practice the queries, it will help much.
Yeah, just practice is what required. Yeah. Okay. So next, full outer join. So based on that, do you want me to explain? In one of you want to explain, or Sai, you want to just tell?
Yeah, I'll take a shot. So full outer join would be intersection of. I mean, no matter. First thing first, without full outer join, if I have to have table employee table or department table, I only get employee or I only get department. When I do a join of those two, I get all the columns. First thing that happens is I get all the columns of both the tables. Now, as the columns are covered, now when it comes to rows, it doesn't matter whether the department table has values or the employee table has values. It will give me if m by m into n rows. How many rows I for it will give me all the rows of department and all the rows of employee, and it will give me all the columns of both the tables.
So yeah, so you do a left outer, right? And this is a right outer, right? So full outer is nothing but it's a union. Union of these two queries is what full outer join. So it's basically the Venn diagram that you put together. It's everything, including the intersection, the whole
shebang.
Yep. That's what full outer is.
The full outer join is this part, the whole thing. Right?
The other way to write this is the on same condition. So the other keyword, we can directly use it. You don't need to do union and all the stuff, but you can just use this full outer keyword. This should give you the whole table. That's it. Both will be the same. You run this query or this query, both are same. That's full outer.
Okay. By the way, when I was sharing my screen, are you guys seeing my screen, or it was like only Prabhu's screen always showing up?
No. Your screen was there.
Okay. Because sometimes they may not see my screen until they switch the screen.
No, I think I unshared it, so they might have.
Okay, then that's good. Yeah. Okay, if you're conscious about unsharing, that's good.
Yeah.
Okay, Prabhu. I think. Do you want to stop it, Prabhu, here because it's 10:10?
Let's just walk through quickly. So
okay.
So because for 1 hour we have just spent like a very small portion of it. So I would like to just cover up to like 5 just quickly. Is that okay?
Sure. Go ahead.
Most of the stuff are like I would like to I don't want to write the query. I'll talk through it.
Okay.
So I have written a query. That's why I don't want to waste time. That's why I have already prepared some of those queries, which is not needed to write it on the screen, right? So that's why.
Sure.
Cross join, it's basically a matrix. Okay, so matrix is what? M into N. So you have M record in your employee table and N record in department table, it multiplies. So that's just a matrix. So that's what it does. So you can use a cross join. What it does is, if you have 10 records in employee table, 10 into 4, 40, like whatever, that 10 times 4. That's it.
So when do you use a cross join? Select star from employee, cross join department.
In my whole career, I've used cross join only once for something, but I don't really remember. For something, I don't exactly remember. But
generally, if cross join is happening, we have to be careful that it should not happen, right?
It will be a duplicate of records multiplication. So we don't generally use it. I don't remember for something I have used in the past.
So
but
it is like every employee table for every employee, is there a record of department? So it's like if a person is working, let's say Prabhu. Prabhu is working in fire department and Prabhu is working in this department. Is that how it works? M into N?
M into N. So I worked in all the 4 departments, but it's illogical. I mean, it's not really a logical thing to do it. See, if you look at this one, so this will be mapped to all the records for all the employees are mapped to the department of 10. So there is no way to scroll down here, but if you go now paginate, you will get to see that. So you'll basically see all the records here. So if you look at this count, right? $60. Okay, so let's see what is the employee count is. EMP.
So what does it actually mean in terms of, it's not, can we represent it in Venn diagram, the cross join?
Cross join is a matrix actually. I don't know. So 15 times, then it should be 4.
4.
Yeah. Right. So I mean, I don't need to write the query. I know that. Yeah. So that's why it's 60. So if you look at this, so every record is mapped to one all the 4. That's what it means. Cross join. It's very rare to ask, but they might, just to test whether you are really in detail with your SQL expertise. Then they might ask you. Otherwise, they don't really go into detail for this kind of. This is a very rare case. Somebody use a cross join. Only crazy people can write the cross join query. So it's actually a duplicate record, right? Irrelevant. So, okay. Let's not waste time. I mean, it's not that.
Yeah, sure.
I wanted to give an idea. If you see any results that when you write queries in your real-time experience, if you see the number of records multiplied, then you're doing a cross join by mistake. So that's when
by mistake. Generally, yeah.
So you have to be very careful. That's why. So you don't want to duplicate your record. So that's for your warning, basically.
If you are getting a product, that means somehow it becoming cross join. That means somehow you are doing something wrong.
Yeah. So yeah. And inline view, we talked about it. What is inline view? It's a lot. We know view. What is view? View is basically a logical table which does not get stored in memory. But inline view is basically a subquery. That's what it's called, inline view. So there's a question they might ask, what is an inline view? So you can tell them like it's a subquery that the result set of a query is being fed to the wrapped query. That's what it is, inline view. Okay. Exist and in. So this is one of the interesting question to ask in an interview. So what is an exist? What is an in? So in, when do you use technically in? So for example, I want to filter my employee table. Okay. I want to filter my employee table for a given manager, right? So I want to find, so let's say this guy where mgr in, comma, I use this guy. So this is what in represent. In is a class. This class can filter your table for a given values. So how many values can you feed here in real time? So when you query any database, this value can be, if you type down values, the comma delimited value, it can go up to 1000. 1000 is what manually it can accept. But you can feed a subquery, like for example, I can write another subquery, like get me whatever, like employee EMP number from employee table, where something like whatever that. So you can write a subquery. There is no restriction. So if the subquery returns 100,000 records, doesn't matter for this, it will work. So this is one of the interview question. So when do you use in operator over exist? So exist does the same thing, but exist work on a Boolean value. So in work on a explicit value that you define here, right? But exist is a little different. I have a query that I have written, for example, here. Look at this one. In versus exist. Yeah, this one. This is one of the interesting query. Why would you use the exist? Exist is faster query. Like if the performance of the query is faster. So when you are involved in performance tuning, like for your query is running too long, so you don't know the reason for it. in real time, what you do is you check whether you have used any in. In is pretty slow because it has to build a result set. Okay. On top of the result set, that is a separate query. It has to run. Then it will, the wrapped query will take the result set and feed into it and get the result. So it's performance overhead. So that's when the interviewer want to know your understanding between in versus exist. So exist works as a logical, Boolean basically. So here I'm not defining any column. Do you see here? I'm not defining any column. But if you look at in, I'm defining which column I should filter. Here I'm not doing that way. Instead, based on this query, what I'm trying to find is who are all my customers database customers in my table have never placed an order. Okay, so I have an order table mapped to a customer, but I want to find, Amazon wants to find all the customer they enrolled but they never placed an order. I want to fire them. They don't want them in my system. Okay, so this is a real-time scenario. So how do you do that in a faster way? Okay, so that's when you use this kind of exist. Is the scenario correct? Did you understand the scenario?
Yeah, I think so. Yeah, I think that's clear. So MGR, or where MGR in, okay.
Okay, so let's do the same query in, right? So I can use the same query in. So let's do this example, right? So let's do this. So I want to find all the customer who has not placed an order, right? So customer ID, right? Customer underscore ID, not in, select customer underscore ID from my orders. Okay. So you know how this query will run in database memory. This will run first. Okay. If your table has 1 million records, so we're not talking about 10 or 20 records here. So the performance for a 10,000 records will be easy. It's quick. But when you go to the real-time project, it will be millions. Okay, millions of records we are dealing with. So to do that, you have to think in a perspective that they will expect you to know how you do the performance tuning. So this is one of the basic performance tuning in general. So that's why I put together here. Okay. So if you look at this, so this will be a query. This query will build the result set, and your outer query will then run next. So this is where it will be. But in this query, I'm doing the same thing with exist. I'm mapping my outer alias with the inner table. So this way, this query will find if there is a record, matching record, because it's kind of a join here between outer table and inner query. So this will run pretty faster than the previous query. That's the difference between exist and in. Okay, exist take up explicit parameter. Sorry, in takes explicit parameter. Exist works on a logical condition that you put there based on the Boolean value, whether the record exists for a given condition. This condition. Make sense?
Yeah, makes sense. So
okay.
if you run both of them will give the same output though, right? It is the way it executes in the SQL that matters, correct?
Yes.
What happens inside the SQL is what we're talking about when it comes to
what we are talking about. Yes.
Yeah.
What happens inside the SQL is
not the end output.
No.
End output is the same.
Yeah, because they would expect in real time, they would expect you to do performance tuning of their query. They might have a big query, but they want to do a performance tuning. But as part of we are talking only on the interview perspective again. So we're not talking about anything or like rocket science, right? So we're just going to talk about the interview perspective, what you are expected to go with, how you are prepared, how you have to be prepared for. So that's what it is.
Okay, sounds good. Yeah.
Okay, so that's it. So delete versus truncate, it's a small theory. What is delete, what is truncate? Does anyone know about it?
Delete is probably truncate. Delete is just deleting from rows. Deleting the rows.
Yeah, truncate.
Never use truncate.
It's same thing, right? So basically both does the same thing. Deletes the data from a table. Truncate does the same thing. But delete, what happens is, delete is a DML command. DML is data manipulation language. Okay, there are 4 commands in, not 4, it's 3, I would say. DDL, data definition language in SQL. DML, data manipulation language. Third one is data commit language. I think DCL they call it as. So delete command copy the data that you're deleting into a temporary memory so that you can roll back. Okay, so you can get the data what you deleted, but truncate does not copy into a memory. So there is no rollback option. Once you perform a truncate command, your data is lost. So that's a difference between delete and truncate. Delete, you can filter some records from a table and delete it. Truncate, you will delete the whole table. That's a difference. Okay.
Okay. So what is it? What is the difference between drop and, so drop will drop the entire table and it's all DML
Their
also.
object, you will drop it.
So yeah, the whole thing will be gone. Truncate will just clean the data, not the table. Right?
Yes. Yep.
Drop will complete. So drop and truncate will have similar effect in terms of entire data being lost. But drop, you will even drop the whole table structure also. So table also won't exist, but you're just cleaning up the data. For truncate, you're just cleaning up the data.
Yeah.
Okay. So can I say delete all and have the same effect as truncate?
No. Delete is completely. What do you mean by delete all?
Like delete all from the table. Delete all from table. If I do that, will it have this?
It has to copy to a memory, temporary memory, and then it deletes it. But you can still roll back. It's not same as truncate. Truncate is completely gone once for all. That's it.
So in Windows, it's like deleting and then having it in memory and you can restore. But truncate, it's completely shift to delete, like you completely lost.
Yep.
Okay.
Yeah, but don't try it in your CCM projects. You're done. You'll be screwed up. So be careful. Okay. Yeah, I think that's good enough for today. So yeah, you guys have any question? It's just a starting part. Like, yeah, it takes time to learn, but go. You want me to share all this notes? Do you have this site already? You don't have it,
No,
right?
no problem. Yeah, share it in the link.
Okay.
Remove the grid and then share it. We'll put it in. So yeah, I'll stop the recording here. Thanks, Prabhu. Anything else? Final comments? Then we can.
No. But anybody wants to ask any question?